In this lecture, we are going to go over some of the problems from chapter 1 and 2 from the textbook Practice of Statistics in Life Sciences. So make sure you read those questions from there, refer to the textbook. So here is the first question. And the first question is actually about the mean, median, and the concept related to that. So the data is given to you regarding omega-3 and omega-6 fatty acids. The distribution is given as right skewed and it is strongly right skewed. So that is one of the key information from the question stem. With high outlier. And then they have asked us, do you expect the mean to be greater than the median, about the equal to median, or less than the median? So that is our first sub question. So whenever we have skewness, our median is resistant to skewness, but mean is not. So meaning that the mean is getting pulled towards that particular side. So if the data is right skewed, graphically it's going to look like this. And in that case, your mean becomes greater than median, and which is also greater than mode. So the answer for this sub question is mean is going to be greater than median, because simply the mean is not resistant to skewness and it is getting pulled toward the skewed side, while the median is resistant to the skewness. So we also explained the y part. Next sub question is calculate mean and m, that stands for median, and then verify the expectations. So first, calculating mean, we always represent in the form of x bar, considering that it is a mean for sample. And we know that that's nothing but summation of all the x values divided by total number of data points we have. That is nothing but n, and xi represent here the summation index for all the summation ranging from the first value to the nth value. So basically what it says is add all this number from the first till this 30th value. So this is the 30th. So these are total 30 data points. So add all of these and then divide it by n. So for the convenience purpose, I've already solved it, and it's going to be something like this. So basically add this number So you can see that the sum comes up to 22.82. So it's going to somewhere around that. If there is some mistake, you can just go back and see the calculation. So let's say the answer is 22.82. So this is nothing but summation of all the x's, first part, numerator. And the denominator, you need all total number of data points. In this case, nothing but 30. So divided by 30. And you should get the answer as 0.76066. If you round it, it's going to be 0.07607, rounding till the fourth decimal. You can also do it till second decimal rounding. Median for this question, we have to make sure that we sort the data, because median is nothing but the middle point of the sorted data points, right? So basically you have to order these x's, all the x values, that is your data, in ascending order. So sort the data in ascending order, and I've already done that here for you. So 0.01, that's the first data point for sunflower, second one is for grapeseed, third one is for cotton weed, and so on. You don't have to write those categories represent or the names of the data points, because they simply ask you in the question the median and see if, what is the relationship between mean and median values. So you already got the median mean value. Now for the median, I've already sorted this data set. So this is a little bit like calculation intensive or sorting process. So make sure you follow those steps. I'm skipping that for the interest of time. So once you sort these data sets, now you know that these are the positions of the data points. So you can simply write this number. This is the first data point, third, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10, 11, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th. And likewise, you can also confirm that you have recorded all the 30 total data points. Now, we know that the median is nothing but the center point of the data. And you can also use this formula n, where n represents the total number of data points plus 1 divided by 2. So n in this case is 30th position plus 1 divided by 2, that is nothing but 31 divided by 2, that is nothing but 15.5, right? So you know that this is the position of the median. So between 15th and 16th. So between 15th and 16th is your median. So now that is only the position. For the mean within the data points, you have to consider these two numbers and take the average of them. So 0.07 plus 0.08 divided by 2, that is going to be 0.075, which is your median, right? Now the last part is verify your expectation. So we already set an expectation that if our data is right skewed, mean is greater than median, greater than mode. So here we have calculated both the mean, which is 0.7607, and let's look at the median here, which is 0.075. So let me just write it down, 0.075. And you can clearly see that your mean here, x bar, is greater than median. So that's how you have verified this explanation.